Hello guys, in this video I'm going to show you how you can use SymPy to solve math equations. So the first thing that we need is define the symbols that we are going to use in our code. So this is what I'm doing here. I'm defining X, Y, A, B, and C as the symbols that I'm going to use in this code. If you don't know what are the symbols and why we need them, I recommend you watch the first video of this series of videos about SymPy, this one, Introduction to SymPy. I will leave the link in the description below, and I'll also leave the link to my website, chemistryprogramming.xyz. I have a lot of articles there that can help you understand how SymPy works and also other articles about programming in general. Here we have our symbols, and the first thing that I'm going to show you is how you can use the solve function with expressions. Here I am defining an expression. So this is the expression that I'm using here. And the solve function will find the roots of this expression, the x values that turns this expression into 0. To use the sum function, you need to pass the expression and the variable. So I'm passing x as the variable, and we have here the values of -4 and 2, and these are the values that are the roots of this expression. So actually, solve turns this into an equation. You can imagine that solve will take this expression, equals it to 0, and will find the values of x that will make this equality valid. Since SymPy is a symbolic package, we can solve an expression using only symbols. So here we have a general quadratic expression. If I run the cell, we'll have here the general formulas that we can use to find the roots of this expression. And these formulas are the ones that we learn as the quadratic formulas for the roots of a quadratic equation. And as we can see, this is a list. So if I assign a variable to this result, you can take each result as items from a list. So we have here the first solution, and here we have the second solution. Since solutions is a list, we can perform this for loop, replacing A, B, and C with actual values, and we will find the roots that we have seen before, -4 and 2. So this is how the solve function works. You pass to it an expression, and this expression will be turned into an equality. So you can read this as an expression equals to 0, and so we'll find the roots of this equation. And since we're talking about equalities, SymPy also has a class to deal with equalities. And I think that this is closer to the mathematical way of thinking about finding the roots of an equation, because this is not an equation, this is an expression. An equation is an equality. Okay, so you can actually create equalities with this EQ class. So we have here the left-hand side. So it's the same expression that I've shown you before. And here we have the right-hand side, that's 0. So let's run the cell. And here we have an actual equation. So this is an equation. And we can also pass an equation to the solve function, and we'll have the same results. But at least to me, this is a more natural way of thinking about solving something, because this is actually an equation. And you don't need to have the right-hand side equals to 0. You can actually write this way, passing 8 to the right side. So you have this equation, and we know that this equation is equivalent to this one. So solving this equation, we will have the same results, -4 and 2. SymPy can also solve systems of equations. To solve a system of equations, you can pass the equations as expressions, as we've seen before. So we have here the first expression and the second one. So you can think of each expression as an equality. So x plus y minus 3 equals to 0, but we don't actually write the equals to 0 when you are writing an expression. Okay, so here we have the first one and the second one, and we have here the first tuple, okay, with the expressions, and the second tuple with the variables. So the variables are x and y. Running this cell, we have the values for x and y. So we have here 6 over 5 and 9 over 5. You can do the same thing passing equations with the equality class that I'm shown before. So we have here the same equations as before, but now written as equations. So the left hand side here with x plus y, and the right hand side with 3, and here we have the left hand side with 3 times x minus 2 times y, and the right hand side with 0. And now I have here the first tuple with both equations and the second tuple with the variables, and running the cell will have the same result that we had before, but at least to me this is a more mathematical way of writing the system of equations using the equality class. This is it for this video. If you want to have more examples and a full text explaining everything, you can have a look at my website, chemistryprogramming.xyz. I've written full text about solving equations with SymPy, with more examples and more details. Okay, and this is it for this video. If you like the video, please give it a thumbs up, and I see you in the next video.